Hello everybody, today I'm going to be covering a topic on both AP Physics 2 and not AP Physics, on the SAT Physics exam. And this is a topic from the unit of optics. So yeah, I'm going to be covering that this time. And yeah, hopefully this can help you in whatever you guys are looking to use this for. It is not applicable to AP Physics C. It's either of the AP exams. It's not applicable to AP Physics 1. So only AP Physics 2 or the SAT subject test. But if you're taking any of those, this video could help you. So what a spherical mirror problem looks like is we have a mirror. Let's say this black curve right here is the mirror, and I'm gonna erase this little dot right here. I know this isn't the best drawing, but I'm not the best at it. I'm still getting used to this. I don't have a drawing pad, so here we are. So I'm gonna draw a little, kind of a long line going through this. It's supposed to be a straight line, but not the best drawer. I'm sorry, guys, but either way, we called it, and so right now I'm gonna start off simple. And I'm actually going to show you two equations. So the first equation, I don't know the name of specifically off the top of my head. I'd have to look at that. Maybe I'll put it down in the comments after the video if I remember. But what the first equation is 1 over d0 plus 1 over d and I will clear this, so I do recommend you write this down if you are taking notes. If you aren't, I would recommend that you take a few notes here and there, not too much of anything. 1 over this is the letter F, and so what this equation does or says essentially is that we're going to define each of these variables. So F is the focus. So if you noticed, a spherical mirror right now, this is just a mirror, and it kind of looks like a parabola. You might have seen one before in your algebra class. I haven't done a video on it, but you may have seen it before. And so if you know, if you've taken Algebra 2 specifically, they don't tell you this in Algebra 1, usually. So the parabola, has something called a focus, and that focal length is F. So basically the focal length is nothing too hard to grasp. So let's say that this is the focus for our parabola right here. It's like around here, and so right here, this distance right here, all the way to like over here, we can put this is going to be F. So with that, this is what F is, and the F in this equation can be used in that way as well. Now what does DO mean? Well, in this case, we're going to have an image show up. So with a mirror, you typically see stuff in a mirror. And so what's going to happen is we are going to try to determine if we have an object right here. And by the way, we represent an object like this. And D0 is going to be the object distance. Actually, let me do this in a different color. Green, a bit thinner, but hopefully this will work. Alright, so this length is going to be D0. And this is the distance that the image is from the mirror. Yeah, let me try to fix that line. Okay, sorry guys. So that's D0. Now, how do you determine this? So now I'm going to put out the equation for a bit. I might rewrite it once I need it again. So what's going to happen with this is light is going to come from this. It's going to reflect off of this image. So how is it going to look? Where are we going to see it? What's it going to look like? So what we do typically, all you need to do, and if you guys know, light rays come from all, like it goes in all directions. Like it'll come in, you can follow, if you can follow my cursor, it'll go in, bounce off in multiple different ways. But we only need to draw two to solve for di, which if you remember was the last variable over there. We don't really solve for the value, but we can determine some information from this. So, what are the two lines that we need to draw, two rays, if you will? So, the first one we can draw goes like this. We can draw it like this, and I'm going to go over F. So, it's going to hit right here, hit the mirror right there. And one thing that's kind of cool about this is when an array is traveling parallel to this line of the central line right here, what it does, if it's going parallel, it reflects back through the focus, which is it's interesting, and it makes this problem a little bit simpler for you to solve. So then you'll see it keeps on going this way, and the line will go that way. I dashed it because I wanted to show you that these are separate lines here. Now, on the other ray that we draw, I mentioned that we draw two rays. This is two rays, but two rays that actually come out from here. So the other ray that comes out from the object itself, the green line, this ray right here comes out from the mirror, technically, and so, well, it reflects from it. And then this one, we actually make it go through the focus itself. Remember, light rays are going in all directions, so some are going to go parallel, some are going to go through the focus as well. So if we draw this right here, you can extend this line all the way to here. And it'll go right here, just like that. And alright, so that's one of, and then you can see, and I drew this little line here without telling you guys. Let me erase it and then explain it really quick. So what we're going to see, what we're going to see is an image of a sort. And you can actually, when we call this a real image, it can be projected on a screen, so to speak. So, and if you put like a screen right here, you could actually see this image pop up. And you might notice a few things from it. You might notice that it's inverted. Whereas this arrow, it's pointing up, that means the image, we call it upright. Here, it's inverted. It's down. It's inverted. Yeah, okay. And it's also longer. You'll notice that the height is much larger with this new image I was made. I should have done it in a different color. But the height is much larger than the original one. So that is one thing that is important to note. And by the way, a little side note here. I am only covering the case for a concave mirror. There's another mirror, convex, which actually you do similarly, but the mirror is like this. But I'm not covering it in this video. I'm just covering it for the concave mirror. So if you do this right now, you can get an image that forms right here. And so once you have that, you can use this image, project it on a screen. This is what we call a real image. You'll notice that real images will always be bigger than, no, not always bigger, sorry, they will always be inverted. We'll also learn that there's also something called a virtual image. And that virtual image will always be upright, the same direction as this. It may be larger, maybe smaller, depending on what we're working with. But you'll notice that if we use that equation that I mentioned earlier, you can actually solve for this distance right here. And I'm gonna mark it right here. Di. This is di, distance of the image from the mirror. You'll notice that di is very big, but di isn't that big. It's slightly bigger than f. And you can actually see this too if you do this. You can actually solve it using the equation. I'm not going to write it out right now, but yeah, you can actually solve it using the equation. So that's what that's the deal with spherical mirrors. If you guys want to see more videos relating to spherical mirrors, please leave that down in the comments below. I did not cover everything. I want to repeat that I did not cover the whole thing. This is not a general covering of the entire chapter. This is actually a very, very small part of it. There's much more. There's convex mirrors, then there's lenses, then there's the double slit experiment, and then there's all that. There's a lot to cover in this chapter, and if you guys want to see more videos of this, please leave your suggestions and feedback down in the comments below. I feel like I didn't do as well on this video as I wanted to, but yeah, either way, guys, thank you guys so much for watching. Please leave a like on the video if you did like it. Subscribe if you want to see more of this. Leave a comment down below with feedback and anything else you want to see on this channel. Thank you guys so much for watching again, and thank you guys for watching, and be sure to watch out for the next video. Thanks.